Today we're going to talk about the web APIs, and the URL to the web APIs is below. And if you navigate to this URL, you come to an API Explorer website where you can test and debug and use the API through a GUI-based browser, which is very handy when you start using the APIs. And so why would you want to use these APIs? And mainly because programmers are lazy, and that's a good thing, because that means that they're using the tools that are available to them and not spending time recreating the wheel. And one of the APIs that we really like is geocoding. We see this as our bread and butter. And geocoding, for those of you that don't know, is assigning an XY coordinate to an address or a place. And then you can use that for analysis or any number of things. So why would you want to use our geocoding? There's a lot of options out there. There's a lot of providers. This API is specific to Utah. That's one good reason. It was tailored to Utah's addresses. The price is right because it's free. We value discrete matching over searching matching. So some geocoding providers will give you a bad match instead of the right match. They just want to give you something. They don't want you to have nothing. Whereas we like to give you the best match or no match. We want you to know that we think this is exactly where the address is and not give you something in the wrong location. We use address grids to help increase the matching rate. And address grids are something that I believe are unique to Utah. They are based off of the unique way that Utah has addresses, where everything is based off of origin, which is usually a temple. And so if a customer or a user thinks their address is here in Sandy, but it's not, it's actually in South Jordan, we can still match that address because Sandy and South Jordan are both in the Salt Lake City address grid. They both have all their addresses derived off of the same origin, the same temple, I believe. And it works the same way with zip codes. So your data might not have the right zip code, but it's close enough, we'll still find that address. Place names are the same, and also delivery points. For people who are familiar with ESRI software, which is probably not very many, it's like a composite locator. It's built on 5 existing locators, and we have to use 5 locators because, well, I'll get to that, but 4 of those locators use street, they're pointed at the streets data. They're optimized and indexed on street names. And so the worst case scenario for why we need 4 locators is because one street can have 4 names. So 50 North Marion Petchy Drive is also North Medical Drive, which is also a highway 282, which is also based on the grid system 1830 East. We can find all those addresses. And there's a lot of those. We also have address points, which are very neat. They've been created by local and city government for uses of voter address validation and some other important uses. And we have over 1 million of these. And given that Utah has a population of 2.5 million people, and let's say 2 people live at a structure, that's pretty close to having almost all of the houses in Utah covered with address points. Like I said, these address points are locally sourced, which makes them strong in rural areas. And when you use our geocoding API, you can choose if you would like to use the address points as your source, the street range data, or you can common things that we handle in the locator or in the geocoding API are address reversals. The post office has a structure for how an address should be comprised, and it's like house number, house address, street number, street address. And so another unique Utah issue is that this address looks normal, but you don't really ever have an address on 707. These are actually flipped. And to some search engines, they're not the same, so they might not be found. So we can detect based on some conventions for these addresses and try them in the reverse order. Address truncations are another thing. Anybody who's managing addresses in a database knows that they get kind of messy. Users don't always put them in the same way. And this is another case where a search engine or a geocoder may not find the right address because the directions are appended to the street and house name. We can take care of that and find the address there. If anybody is using GIS currently, you probably have all your data stored in Spatial Reference. The state standard is UTM Zone 12 North, and the geocoder can give you back your geocoded result in pretty much any spatial reference you would like. WGS84 is very common. It's the flat long projection, and if anybody uses Winkle Triple in GS, we can do that too. As far as formats go, we use web mapping frameworks to show this information to people, and ESRI is one of our major vendors. So if you're an ESRI JavaScript developer, we can return the JSON from the web API call so that you can very easily put it into an ESRI graphic and display it on the map. For the open source folks, we have GeoJSON as well, so if you're playing with Mapbox or any of the other OpenStreetMap type of mapping frameworks, this will plug in nicely as well. We offer suggestions when geocoding so that if the person doesn't give the exact right address, we can return a predefined number of addresses that are ranked by score. So if you don't get a perfect match, here's the other 5 addresses that this could be, and so you can let them choose. Sure.
Would you call it like an address standardization, like we do for the mail system, mailbox, for address mailing and stuff like that? Would you suggest anything like this before you go out and search for an address?
Well, this would be, so, what, can you rephrase that?
Well, I don't know, we were to put in an address for mailing, we call the mailbox.
It's the 1+.
Yeah,
Okay.
that's an address standardization.
Oh, really? So we run the address that when it comes through a parser to try and split out the parts and then put it back together in a standardized way. It might not be the same as the post office, but we use it in a way so that we get the best match rates.
We've done some other work to try to work with those addresses because we don't have address cleansing. So we do have something where we can pre-run it and go, well, get rid of the suite numbers, take all that stuff out, or parse over it when the address is being broken up and run through the geocode. So there is some work we've done to try to deal with bad addresses.
So I wouldn't necessarily depend on it as an address standardization tool, but if we don't find a match, then there's a pretty good chance that the address is either invalid or not well-formed. Sure.
How current does the database get updated with new build-outs, with new developments and things like that?
So we do, is it quarterly updates, Matt, on the range data?
Well, at least quarterly. There is some monthly. Wasatch Front, of course, is updated every month, but the rural parts in Utah, sometimes it's more of the as-needed quarterly.
And then we've also built bump stickers to bribe questions, but don't see me after. And like I said, so we rank those suggestions by score, and it's a 0 to 100, and you can input, when you make your request to Geocode, the lowest score you want to accept. So you can make a pass through your addresses with a 90% or 100% match rate, and that will give you the definitive, this is where this address is. But if you're wanting to try and get everything, then you can lower that score, and you might want to do some QA on it afterwards. A second API that we offer in the geocoding realm is reverse geocoding. And this is where, say you have a device and you want to know what is the nearest address to me. And this will give you back the nearest address. It's based on address ranges. So a street it starts at 0 and it ends at 10. If you're in the middle, then we think you're 5. The address point of the mailbox may be over here, but that's how that works. And you can input a distance as to how far you want to search to try and hit that line segment. You can pass whatever you want as far as the spatial reference. The state standard for spatial data is UTM, but you can pass in the WGS84 lat long spatial reference code, and we'll handle that for you and give you back the right address. We also do route and milepost, and this is handy for when you don't have a physical address nearby, but you want to know where you are still. So you can pass in like 15 north and milepost 300, and it goes to 3 decimal places as far as accuracy. So that's pretty neat. And then we also do that in the reverse fashion. So if you are highway patrol, you want to know where you are, where there's crack shift or something, you can input your XY from your phone and get back the route and milepost that you're on. Okay, so here's where I bribe you for questions, but I haven't had to do that. So, does anybody else have any other questions so far? Sure.
That routing thing that he was talking about, milepost, is
Yeah.
that statewide then? If you're out in the middle of a stick somewhere and for some reason you woke up and you have no idea where you're at, and there's a milepost there.
It
You wanna
works.
know the closest
Currently, I think we do state and federal highways. So we don't do it on local roads. And I'm not sure. Matt, do you know that answer?
I'm not sure either, but yeah, I'm sure it's just state and federal. Yeah.
And then did you have one too as well?
Oh, yeah, you mentioned, you can, return the suggestions ranked by score. So does it mean, like, if I want to have, 100%, then you just limited the search range for that, maybe like UTM value, something like that, to be 100% match, and if it's, less, maybe you just, make the range wider, is that how it's working?
Well, the address is ranked on score based on some internals of the locator. So like if you misspell words in the address, you lose score. If you don't have a suffix direction, so like if you say 300 South Temple instead of 300 East.
Oh, so it's not
Then-
like a range, it's
No,
just
it's just a score.
similarity in
Yeah.
the, search word.
Yep. And so with suggestions, you can put suggestions at 0, and you only get 1 result. And then you can put the score at 100, and if you don't get a result, then you know that the address wasn't perfect. Which I wouldn't suggest doing 100. You'll still get good results around, above 70 or 80. And we have a pretty good default set for you. All right. So, more questions?
Yeah, municipalities, are you able to give back the exact municipality that address is in?
The address itself does not come back with the municipality, but that's a great segue into what we'll talk about.
Okay.
So we have the State Geographic Information Database, which we call the SGID. It does not have over 300 data sets. It has and you can search any of those feature classes. So, and you can get back the geometry, you can get back attributes, and this is very useful for finding out what happened at this location based on whichever layer you're interested in. Some things that we do now are political districts, voter stuff, like what voting district am I in, who's my representative, who's my, school district, I think I said. And then you can fine tune this search with a predicate, which is just like a T-SQL where it was. And you can also pass in a geometry. So if you geocoded an address, you could take that XY, pass it in to the search API with the municipal boundaries as the layer, and ask for the name, and then you get what you're interested in. So I think it said this, but the first thing you want to do when using the search API is figure out which layer you want to use. And there's 3 ways to do this. Our catalog, which is this kind of a specialized piece of software that I wouldn't imagine a lot of people have access to. Our GIS portal website has metadata and all of our feature classes listed on it. And we also have an API that you can use to find the feature classes. And they're all organized into some ISO standard to help with the filtering. So there's like political, boundaries, hydrology, stuff like that. And then finding out what attribute is important to you and your users for your application. You could also use our catalog or the GIS portal to download the data, but then you need something to view the data in. It's easier, I think, to use the API. So you pass it in the feature class, and it tells you all the fields that are there. And you can also return the geometry. And there's 2 ways to do that. You get the shape with the token shape ampersand or shape ampersand envelope. The shape ampersand gives you a GeoJSON representation of the shape that you can use with mapping frameworks like front-end mapping frameworks. The envelope is really nice if you just want to zoom to a feature. Like, take me to the city of Salt Lake. We'll give you 4 points. There's not a lot of data on the wire, and then you can zoom your map to that area. But like we were talking, geocoding address is cool. It's only half of the battle. But using the search API to figure out if you're in blackberry habitat or a wildfire perimeter or municipality or voting district or anything, really kind of adds value. So chain requests together to gather useful information is really what these pieces, how these pieces I think should be used. So do we have any questions about searching? Everybody's got that.
So, for a question mark, if I'm here, I want to find the closest gas station. How to use your API to search it?
So to do that, you could input a shape. So you could take, like, if you're using like a phone, you have a point. Like I'm in,
Current location.
yeah. And then they also sometimes will say this is accurate to 30 meters, and you'll get what we call a buffer. So if you were able to take that point and buffer it, which would just be making that point to a circle, you could send that to the service, and that shape then becomes like a cookie cutter, and the data you want to search becomes like the dough, and you say what's in here, and then we can return it.
So do you have any features like this is a restaurant that say gas station have something like that, or you only have the address?
We have, I don't believe we have restaurant information or data like that. It's mostly data that, well, I'm not sure how to answer that. Matt, how do we decide we don't have the capacity to curate infrastructure like restaurants and stuff like that, but we do have like the state fuel sites. So if you needed to fuel up a state car, you could figure that out. Anything else? All right. So now that we kind of have the general idea of what you can do with it, let's look at how you can get started by using the API mapserve.utah.gov API Explorer. And so when you go to that website, you will see little blocks like this for each API. And they have a bunch of information in here that tells you how to formulate your request to make a successful request. So in the upper left-hand corner, we have the HTTP verb. And this is the type of request you would send using some sort of programming language. We use get and post. Then we have the format of the URL. And so everything comes after api.mapserve.utah.gov. Here, to do the search, you would say // search. And the syntax here is anything beginning with a colon is a required parameter. So feature class is required and return value is required if you want to use like the bare minimum to do a successful search. We need to know what layer you want to search and what information will go back. Anything less wouldn't be really useful. And then below, you can see that feature class, that token, has an input field, and it's of type string, and it's also required. And so if you wanted to test the API, you could just type in, for example, county boundaries. And you can all read that, that's pretty big, that's great. And all of the optional parameters are appended to the query string. And this makes it really easy for us to add new functionality as we go on without breaking any existing applications, because the query string can go in any order, it doesn't matter. And so things like the predicate, when using the search API, are optional. So if you wanted to search for municipal boundaries where the name starts with K, this is where that would go. And then it just gets formatted to required, question mark, optional. I mean, that's, if you're a software engineer that works with HTTP, this is pretty familiar. But the one drawback to using HTTP as a transport method is that you can't use URL reserved words without escaping them first. So the ampersand and the question mark have a lot of meaning in this URL. And so if your data has a question mark or an ampersand, things go bad quickly. So there's a little data cleansing that needs to happen if you're going to send your whole database through the geocoding or the search API. And then it's very easy to get started. We have a great getting started guide that walks you through it. It's on developers.mapserve.utah.gov. And the first thing you do is register. There's no cost. We just like to have a list of users so that we can contact them, and we like to just know who's using our stuff. That's basically. And then you decide what kind of application you're going to create. And we split these into two different types of applications. And we do that so that you can generate an API key to use the API. And so for server and desktop use, which are things that run on a computer or a server that have like a static IP address, things like Python and C# apps, you create an API key with the IP address of that server, and that's how we can validate that the request is coming from the computer that the API key was generated for. Some common issues are things like people using internal IPs, which don't propagate to us. So the other type of applications that we classify are browser-based applications. So these are things like a website that you run that has a map on it, and you want people to be able to geocode or search and display things on the map. And they're a little more tricky because everything's public. People can right-click and view the source and steal your API key if they wanted to. They couldn't benefit from that, but we don't want people doing that. So we use regular expressions to match the URL, the URL that the request is originating from, coming to the API. And so, for example, we have an application here, PLSS, it's public land survey stuff. And the text in pink would be all valid regular expressions to match requests originating from this website. One nice thing about this is that we can then track usage of the API key, which we show in the developer dashboard. We have that disabled currently while we are upgrading our system performance, but it's really handy to see how useful features are in your website. So you can kind of gauge, is this something that we should provide more of, or maybe it's our users don't use this, so why are we offering it? And this works for like third level domains as well. You can throw an asterisk in the front there. If somebody puts www in front, it'll still work, or anything like that. And then we have samples of how to use the APIs. We have this geocoding samples GitHub repository, and you can kind of see the URL up there. This presentation is also public, so the slides will be available if you want to look at it later. And this repository has a C# example, a JavaScript example, Python example, a Ruby example, a PHP example. And if you didn't see your language up there and you would like to contribute to an open source project, this would be a great opportunity. So please do that, we would be happy. And then just some general things about the API. There's no limits or throttling now. If you are courteous to our servers, then we won't have to. Ideally, we would like to be able to scale, but people have millions and millions of records and databases, and if everybody is geocoding at the same time, then our people, it won't be great. So we recommend doing large jobs during off hours. This API is also portable, or so we could set up a specific instance for your agency if you needed to have, 100% access. And that's it. So I would love to hear questions or comments or anything you have to say.
We've talked about mapping out our licensees so we can see who's in an area when the auditor goes out. How big of a request would you want us to do after hours? 1,300 addresses be what you want us to do in off hours? Is that considered low? Or?
We would consider that low. Since it is a web server and you can basically send asynchronous calls at it, you can send 1,300, 13,000 at once if you were, if you wanted to write your code that way. If you were to send one after the other and maybe give it a break between like a few milliseconds or something, that would be fine. That wouldn't disrupt any other processes that we have going on, and I don't think users would notice that. Yes?
Who's
I'd say that's like the major one for me is a lot of health stuff is coming through. And I talked to some folks the other day and they wanted to throw 1,000,000-something addresses at it. And elections, and if you go out to elections.utah.gov, that map on that site utilizes these services.
The one-stop business registration uses this a lot. So every time you have to renew or register a new business, they geocode their address to make sure, and we get that feedback as well, so we improve on the locations.
Law enforcement using this.
It's they're in the queue. Not that's in the queue. Public safety's in the queue for crash locations, geocoding crashes. I think that's going to get fed into the highway patrol app that's in the queue to be built for where to best place resources. Keep going, yeah.
Okay, so I used to build donor data warehouses in higher education, and we used to send our alumni addresses through the natural chain address system, because that's pretty much considered the gold standard. So when you said earlier that you could submit and you would give them a 98% confidence rate or something along those lines, are you saying that's a positive match that an address exists, that's a good address? Is that what you're doing?
So the score is per address. So we don't guarantee that if you send us 100 addresses, we're going to be able to geocode 98% of them. If you send us those addresses and they're in good shape and they're all in Utah, then
So you'll validate that that's a good address?
based on the score, yeah. So if the score is anything below 60 or it's a 0 because we didn't find anything, then most likely it's not a good address.
So why would tons of marketers just be using this? Because it sounds like you've got a repository that's going to be fairly.
I think our biggest shortcoming is that it's only Utah. It's not global. I think that's the Mormon Church has come to us since they do global stuff, but they wanted to branch their logic for geocoding if it's in a Utah zone to use our location. But as far as other people that we see registering, we see like real estate agencies. But as far as why there are not more people are using it, maybe it's we don't have the marketing budget.
Well, you understand that's the big knock, you know, with a lot of digital marketing.
Yeah.
It makes sense that addresses don't exist, and you can clean those, you can show that there's a cost saving and ROI with that.
Yeah, absolutely.
For the storage thing, is it, do you calculate on the fly or it's already?
It's on the fly.
So that means this one, if I send, a few requests, this one will be.
It happens in milliseconds. Even with HTTP latency, geocodes take 100, 500
I'll give
milliseconds.
you a very low score.
If you give me a low score, that just means that we're going to give you more addresses back. But if you say I want to accept an address above 20, but I only want one because you gave no suggestions, you're going to get the same payload over the wire, and it's going to take the same amount of time. But if you give us if you say I want something over 50,